Hey guys, welcome back to Akacademy. I am Akash, and in the last video we had discussed some previous year questions from the solid state chemistry. In this video we are going to solve some previous year questions from the chemical kinetics, right? And let me tell you one thing, that if you are watching our video for the first time, so please subscribe our channel and please hit the bell icon so that whenever we upload any video, so you will be notified. Now let's begin with the topic. So the first question is the temperature dependence of a reaction is given by K is equal to AT square exponential minus E naught by RT. The activation energy of reaction is given by. So they have given one equation which is temperature dependent, right? Which is equal to K is equal to, you have AT square exponential minus E naught upon RT, and you have to find out the EA you have to find out, which is the activation energy. So now how you can solve this one? Let's see what we can do. We can take ln over here. So this will become ln K is equal to, this will become ln A plus ln T square plus ln e raised to minus E naught upon RT, right? And after solving this one, you will get ln K is equal to, this is ln A plus 2 ln T plus, here minus E naught by RT will come this side, so this will become minus E naught upon RT, and ln E will be equal to 1. So this much we have. Now after this d by dt, now let's differentiate it with respect to temperature. So this will become ln K is equal to, because A is constant, so this will become 0, right? So this is 0 plus, here ln T is there, so this will become 2 into 1 by T minus, this is E naught upon R, and the d by dt 1 by T. So d by dt 1 by T is equal to minus 1 upon T square. After solving this one, you will get it as minus 1 upon T square. So now put it over here. So this will become d by dt ln K is equal to 2 divided by T plus minus, and minus will become plus 1, right? So this is equal to minus 1 upon T square. So after putting this value over here, this minus and this minus will become plus. So this is plus E naught upon RT square. So you got this much, but you have to find out the energy of activation. As you can see in this equation, there is no EA term, right? So how you can find out? So what we know, we have K is equal to AE raised to minus EA upon RT. This is the equation, you know, activation energy is here. So here what we can do, we can take ln also. So this will become ln K, here we will have ln A, again minus EA upon RT, right? And d by dt ln K will be equal to, d by dt ln K will be equal to, here ln A will become 0, here we will have EA upon RT square. Again the same thing, whatever I did over here, just you have to do again the same thing on this equation. First of all, you have to take the log, right? After taking the log, what you have to do, this will become ln E, so ln E will be equal to 1. So here we will have minus EA upon RT. So what will happen after differentiating it with respect to temperature? So d by dt ln K will be equal to EA upon RT square, because in this case also minus 1 by T is there, right? So 1 by T, d by dt 1 by T will be equal to 1 upon T square, right? So this one, so after putting this value over here, you will get d by dt ln K is equal to EA upon RT square. So this is your second equation and this is your first equation. So now let's put the second equation into the first equation. So this will become EA upon RT square is equal to 2 by T plus E naught upon RT square, right? So we will shift this RT square on this side. So what it will become? It will become EA is equal to 2 by T into RT square plus E naught upon RT square multiply by RT square. So this RT square and this RT square will get cancelled, and this T will cancel this one, right? So EA will be equal to 2RT plus E naught. Now let's check whether it has been given in the option or not. So this is the answer. So what you can see in the third option, we have E naught plus 2RT, which is the correct answer. So the third option is the correct one. So I hope you understood, and this question was asked in June 2015. This is a very easy question. Now let's see the next one, which is for a reaction 2A plus B is equal to 3Z if the rate of consumption of A is 2 into 10 raised to minus 4 mole per dm cube second, the rate of formation of Z in mole per dm cube per second will be. Now in this case they are asking about the rate of formation of Z. So now first of all let's write the reaction, which is 2A plus B is equal to 3Z, right? And you have been given dA by dt, rate of consumption of A, which is minus dA by dt. You have been given this is 2 into 10 raised to minus 4 mole per dm cube and second, right? And you have to find out the dZ by dt. This is you have to find out dZ by dt is equal to, you have to find out. So what you can do, you have to just write one equation, which is 1 by 2 dA by dt. From the rate law you can write this one, right? So this will become 1 by 2 dA by dt. Here we will have minus sign because A is getting decomposed, or consumption of A is here. So this will become minus 1 by 2 dA by dt is equal to dB by dt, which will also have minus sign, is equal to 1 by 3 dZ by dt, because the concentration of Z is increasing, so we will have positive sign over here. So what the relation we have, this is minus 1 by 2 dA by dt is equal to 1 by 3 dZ by dt. Now let's put the value of this minus dA by dt over here. So we have this minus 1 by 2 dA by dt is equal to 1 by 3 dZ by dt, right? So what we can do over here, we will put the value of minus dA by dt over here. So this will become 1 by 2 into, here we have 2 into 10 raised to minus 4, and this 3 will come this side and multiply by 3. This is equal to dZ by dt. So 2 and 2 will get cancelled. We will have 3 into 10 raised to minus 4 is equal to dZ by dt. So this is the correct answer. Now let's check. So the first option is the correct one, which is 3 into 10 raised to minus 4, right? Mole per dm cube per second. And this question was asked in June 2015 for 2 marks. So this is also very easy question. Now let's see the next one, which is the concentration of a reactant R varies with time for 2 different reactions as shown in following plots. So here you have 2 graphs actually, and you have to find out the order, right? They are asking about the order. So now let's see how you can do it. So what you have in this case one graph as this, like this, and the second graph you have like this. Here we have R, here we have time, here we have R, here we have time. Now first of all you should know the reactions, you should know the equations for the zero order, first order and second order. So what we know in the zero order reaction, we have the equation R is equal to R naught plus KT, sorry, not plus minus KT, right? So this is the equation for the zero order reaction. And what we have for the second order, we have 1 upon R is equal to 1 upon R naught plus we have K into T. So this is the equation for the second order. Here we have 1 by R, right? So now what you can see over here, in this case, if I try to write it in the form of y is equal to mx plus c, so we can write it like this, and here in this case we can write it like this. This is y is equal to 1 upon r naught, right? So this will become c plus m into x. So here we have m is equal to k, and here we have m is equal to minus k, right? So minus k means we have negative slope over here. So in this case you can observe we have negative slope, and here this is y, this is r term, and here you have time, this is x. So from this graph it is clear that this is zero order reaction, right? This is the zero order reaction. So either the first one or the third one will be the correct answer, and after this we have to see for this next one. So this is the equation for the second order. As you can see, this is following this graph actually. So we have this 1 by r, and we have t, and the slope is also positive over here, and 1 by r naught is intercept, right? So this is the second order reaction. So we have this as second order, here we have zero order, so the third option will be the correct one, where we have the 0 and the 2. So this is the correct answer, and I hope you understood. First of all, we have this graph, and what we should know all the equations of this first order, second order, zero order, and from here we can find out what is the slope actually and how the graph will be. So this is very easy question. I hope you understood. Now let's see the next question, which is for the following reaction. Here we have one reaction, and we have to find out the dB by dt. Now let's see how you can solve this one. So here we have, let's write the reaction first. Here we have A, here we have K1, K minus 1, here we have 2B, right? And the second reaction is B is getting converted into C, here we have 2. So they are asking about the dB by dt will be what? Now let's see how you can solve this one. So let's write the first equation, so which is A is getting converted into 2B, and here we have K1, right? The rate as K1. So for this we can write it like dA by dt is equal to, here what we have, 1 by 2 dB by dt. This one is equal to, we can write it K1 into A. Minus dA by dt will be over here, right? So this is how you can write this equation, rate expression for this equation. And for the second reaction we have this 2B is getting converted into A. Here we have rate as K minus 1, right? So in this case how you can write 1 by 2 dB by dt minus dB by dt is equal to what we can say dA by dt or K minus 1 B square. So this is what we have, right? We can write it like this. And for the third one we have B is getting converted into C, and here we have K2. So I can write it like dB by dt minus dB by dt is equal to K2 into B is equal to dC by dt. I can write it like this. So this is the third equation, and this is your second equation, and this is your first equation. So from the first, second and the third, if we have to find out this dB by dt, so what we can say, dB by dt will be equal to rate of formation of B minus rate of deformation or decomposition of B. So here we have dB by dt is equal to rate of formation of B minus rate of deformation of B. Now let's see how you can do next thing. So what we have in this case, the B is getting formed, right? So we have dB by dt is equal 1 by 2 dB by dt is equal to K1 into A, right? So what we can say, dB by dt will be equal to 2K1A, right? So from here we got this 2K1A. So this is the rate of formation of B. But in the case, in this case we have dB by dt, right? Rate of deformation. So minus dB by dt. Here I can shift this to on this side. So this will become 2K minus 1 here B square. So this is the rate of deformation of B, and in this case also it will become K2B only, right? So this is the rate of deformation, and this is the rate of deformation, and this is the rate of formation of B. Now put all these values over here. So this will become 2K1A. So this is the rate of formation minus rate of deformation is 2K minus 1 B square plus K2B. Now open this bracket, so this will become 2K1A minus 2K minus 1 B square minus K2B. So this is your answer. Now let's check it whether it has been given in the option or not. So the second option you can check, this is 2K1A minus 2K minus 1 B square minus K2B. So the second option is the correct one, where you can see this one, right? So I hope you understood this question. And now let's see the next one, which is if the rates of a reactions are R1 and R2 at concentration C1 and C2 of the reactant respectively, the order of reaction N, assuming that the concentration of all other reactants and temperature remains constant with respect to that reactant, is given by. So here almost everything is constant, right? So you have the rate of reaction R1, right? Here we have rate of reaction as R1 and concentration is given as C1 and C2 and rates are R1 and R2. So they are asking about the order. If the all other reactants, concentration of all other reactants and the temperature is constant. So in this case what will happen, here if we have this rate, right, and here we have this concentration, so the rate will be, this rate will be directly proportional to the concentration raised to N, where N is the order, right? The rate of the reaction will be directly proportional to the concentration raised to N, which is the N is the order. So now what we can say, here we have this R1 will directly proportional to C1 raised to N, right, and R2 will directly proportional to C2 raised to N. So this is equation 1 and this is equation 2. After dividing equation 1 by equation 2, so this will become R1 by R2 is equal to C1 by C2 raised to N. So we have this equation. Now we got this one. After this we have to find out this N. So how we can find out? So now let's write it. So we can take log, right? So we can take log or ln. Now let's check in the option whether the log or ln has been given. So in the option we have log. We can take log, so this will become log R1 divided by R2 is equal to n log C1 divided by C2, because n will come this side, right? N will come this side. So this will become log R1 divided by R2 divided by log C1 divided by C2 is equal to n, where n is the order. So n will be equal to log R1 minus log R2 divided by log C1 minus log C2. So this is the answer. Now let's check it. So in the first option we have log R1 minus log R2 divided by log C1 minus log C2. So the first will be the correct answer, right? So this is also very easy question. Now let's see the next one, which is for a reaction with an activation energy of 49.8 kilojoule per mole, the ratio of rate constant at 600 Kelvin and 300 Kelvin is approximately. So they are asking the rate constant, ratio of the rate constant, right, at 600 Kelvin and 300 Kelvin. So we have to find out the K 600 divided by K 300. So now let's see how you can solve. So what we know, we have the formula where we have ln K1 by K2 is equal to EA upon R. Here we have 1 upon T2 minus 1 upon T1, right? And you have been given the T as 600 and 300 and the activation energy EA is equal to 49.8 kilojoule per mole is equal to 49.8 into 10 raised to 3 joule per mole, right? Joule per mole. This kilo, 1 kilo, right, will be equal to 10 raised to 3. Now let's see how you can solve. Here R is also given. R is equal to 8.3 joule per mole per Kelvin, right? Now put all the values over here, because here we can consider this as 600 as T1, right? T1 and this 300 as T2. This 600 as T1 and 300 as T2. So put it over here. So this will become ln K600 divided by K300 is equal to EA is what? EA is 49.8 into 10 raised to 3 divide by R is equal to 8.3. Here we have 1 upon T2 is how much? 300 minus 1 upon 600. So now let's solve this one. So this will become 49.8 into 10 raised to 3 divided by 8.3, and here we have 600 minus 300 divided by 300 into 600. So 600 minus 300 will become 300. So I can write it as 300, and 300 will be cancelled. This 300, right? So we will have 1 upon 600. Let me write it over here only. So this will become into 1 upon 600. After this, what we can do? We have this as 1000, right? So these two 0 will cancel these two 0, and 6 multiplied by 8.3 will be approximately 49.8. So we have 49.8 divided by 49.8 into 10. So 49.8 will get cancelled. So we will have only 10. So what we have? We have now ln K600 divided by K300 is equal to 10. So we have K600 divided by K300 is equal to e raised to 10. Got it? So we have this as answer. Now let's check. So the fourth option will be the correct one, where the answer is e raised to 10. So I hope you understood. So this is a very easy question. Now let's see the next one, which is, according to transition state theory, the plot with slope is equal to minus delta H dagger upon R is. So actually you have been given the slope, and you have to find out the actually x and y coordinates value. Now let's see. Slope is equal to minus delta H dagger upon R. So you have this one. So in transition state theory, we have one equation which is called Eyring equation. So now let's see what is that. So we can find out the rate. So K is equal to KB. Here we have RT upon H. Here we have e raised to minus delta H dagger upon RT and e raised to delta S dagger upon R. So as you can see, this is constant and these all are constant. So we can take this T on this side. So this will become K by T is equal to KBR upon H e raised to delta S dagger upon R. So this is one constant, and here we have e raised to minus delta H dagger upon RT. Now take the ln. So this will become ln K by T is equal to ln KBR upon H e raised to delta S dagger upon R. So this is the first term, and you have here what we will have, minus delta H dagger upon R multiplied by 1 by T. So I can write it into the form of y is equal to mx plus c, right? So what we have, x is equal to 1 by T and m is what, minus delta H dagger upon R, and y is equal to ln K by T, right? So what we can say, we have the coordinates y as ln K by T and x as 1 by T. So now let's see. In the third option, we have ln K by T versus 1 by T. So this will be the correct answer. So third is the correct answer. So I hope you understood all the questions, whatever actually has been solved over here. So if you like this video, please comment down and let me know how it is, and share with your friends and subscribe our channel. Thank you so much for watching.